Legacy enterprise software in regulated industries is notoriously rigid. To meet compliance requirements, systems are typically over-engineered, resulting in massive, slow-moving monoliths. But ensuring strict data governance does not inherently require a slow architecture. This map represents the data topology of QAtrial version 3.0.0. It is a full-stack quality management platform built for regulated environments, containing over 25,000 lines of code across 130 TypeScript files, mapped to 15 distinct data clusters. Building software for MedTech and Pharma comes with a specific engineering constraint. Every action must be meticulously tracked, verified, and audited. Historically, developers assumed that satisfying these requirements meant adopting bloated enterprise stacks. QAtrial takes the opposite approach. It enforces rigid ISO compliance and data governance using a lean, modern stack, consisting of React 19, a Hono backend, Postgres, and the Prisma ORM. A modern, transparent stack leaves no room for hidden logic. By applying strict engineering discipline to lightweight tools, we create a system that is significantly easier to audit and secure than an obscured legacy platform. The front-end architecture is designed to operate in two completely distinct environments. The exact same React components execute, whether a user is running a standalone local evaluation or a fully persistent production deployment. This diagram illustrates the data flow. On the left is standalone mode. When the application boots and detects no backend connection, the React layer routes all data directly into 20 Zustand stores. These state managers are backed by local storage, allowing the application to function entirely within the browser. When the application detects a valid server configuration, it enters server mode. All operations shift away from local storage. The front end routes through an API client wrapper that extracts the payloads and executes standard REST API calls to the backend. To keep the initial load minimal, the build pipeline uses Vite to split the codebase into 14 separate chunks. Heavy components, like the AI configuration panels and complex compliance module templates, are strictly lazy-loaded only when a user navigates to those specific routes. Decoupling the UI state from the storage mechanism means NTMiners can run zero setup local evaluations immediately. There is no need to maintain a separate, disjointed codebase for demonstrations versus the production server. Network security relies on a dual-token JWT architecture. The client holds a short-lived access token that expires every 24 hours, paired with a 7-day refresh token stored securely on the client side to silently obtain new credentials. We can map the request lifecycle through this layered security gate. The require auth middleware intercepts every inbound API request. This first layer extracts the bearer token and validates the user's identity statelessly before any logic is permitted to execute. Immediately after authentication, the request hits a second barrier. The require permission middleware chains onto the request, checking the validated user against a strict 5-role matrix to determine if they hold the specific mutation or approval rights for that endpoint. Enterprise Identity Management utilizes the standard OIDC authorization code flow. This configuration allows seamless single sign-on and auto-provisioning from identity providers like Okta or Azure Entra ID.
By chaining identity verification and role-based authorization at the absolute edge of the middleware loop, we guarantee that no unverified or unauthorized request can ever reach the database layer. The data foundation is a Postgres 16 database managed through the Prisma ORM version 7. The schema is highly normalized, structured around 15 core domain models covering every entity in the quality management lifecycle. Regulated environments demand exact sequential IDs, like REQ-001, for all records. Generating these IDs requires strict database transaction locks. This ensures that if multiple users submit records simultaneously, the database prevents race conditions and eliminates the risk of duplicate sequence numbers. Every state change is recorded in a centralized audit log table. A single entry captures the user ID, the exact UTC timestamp, the origin IP address, and complete JSON snapshots of both the previous and new values of the modified record. The critical constraint of this audit trail is that it is strictly append-only. There are 0 update or delete endpoints in the REST API for audit data. Once a record is written, it is permanent. Combining database-level transaction locks with forced append-only logging establishes absolute data integrity. This design strictly satisfies the uncompromising regulatory demands for total non-repudiation. Integrating artificial intelligence presents a distinct security challenge. For pharma and medical device companies with strict data governance, executing LLM logic or storing API keys directly in the browser is absolutely prohibited. This animation details the proxy architecture. The client sends a raw prompt payload to the Hono backend. The server intercepts it, securely injects the API keys from protected environment variables, and then forwards the request to the external LLM provider. Large language models are prone to formatting hallucinations. The returning payload runs through an automated JSON schema validation loop on the server. If the model output deviates from the expected structure, the server instantly triggers auto-repair algorithms to correct the syntax before it ever reaches the client. Every generation undergoes provenance tracking. The system permanently logs the specific LLM model used, the exact token count, and the unique ID of the human reviewer who accepted or modified the final output. By isolating the AI behind a secure server proxy and enforcing strict output validation, the system transforms an unpredictable language model into a reliable, verifiable enterprise tool. Ultimately, all of these security, data, and logic layers must be deployed efficiently. We collapse this entire architecture into a single, highly stable artifact. This is executed using a multi-stage Docker build. The three-stage compilation pipeline starts with a node environment building the React frontend. Stage 2 simultaneously generates the Prisma client and Hono server logic. Stage 3 produces a single runtime image, discarding development dependencies to serve both the API and UI from one process. In production, the Docker Compose configuration utilizes rigid health checks. The application container is explicitly blocked from booting until the Postgres database confirms it is fully initialized and ready to accept connections. Enterprise-grade compliance does not mandate an unmanageable sprawl of microservices. QAtrial demonstrates that a tightly disciplined, modern monolith provides the highest level of verifiability required for heavily regulated environments.